in section 7.3, I had alluded to this in the prior notes, the zero product property. If you have two things that are essentially multiplied together and they equal zero, then at least one of the things that you're multiplying must be zero. And you can see this play itself out. If you have two numbers multiplying, 9 times a number equals 0, well then right, one of the numbers must be 0. And if 0 times 4, we know what that is equal to. That's 0. So then if in algebra, if you have, some value a and another value b multiplied together, then either a is equal to b, or a is equal to 0, or b is equal to 0. One of them has to be equal to 0, and that just preserves, properties of multiplication. So now if we've got essentially this factored form polynomial, and it's equal to 0, well, we have to let x minus 3 be the a, and we're going to let the b be x plus 8, and a times b is equal to 0, so you know that a is 0 or b is 0. So in principle, right, we can now figure out essentially what's called the x-intercepts, the zeros. Some math textbooks, as you advance, call this the root, right? So let's clarify that. We have the zeros of a polynomial. The x-intercepts or the roots, they're all the same thing, right? They're all the same things. They're essentially what makes a polynomial equal to 0, and they're based on this simple principle that two things multiplied together, one or the other, or even both, have to be 0. So if x minus 3 equals 0, then x must be 3. And if x plus 8 is equal to 0, then x must be negative 8. Oh, and then last little bit, right? This, or this, they are all the same thing. If I ask you to find the 0 of a polynomial, if I ask you to find the x-intercept of a polynomial, if I ask you to find the root of a polynomial, these are essentially all the same things. So essentially, this equation is equal to 0 when x is equal to 3 or when x is equal to a negative 8. In either case, that's when this equation is equal to 0. And on the graph, right, that's when y would be 0, is when x is 3 or when x is negative 8. And they'd be the 2 points at which the graph would cross the x-axis. So recall that the solutions of an equation are the zeros of the related function. So the solutions of this equation are the zeros of the related function, basically x minus 3 times x plus 8. Because they satisfy the equation when f of x is equal to 0. So essentially the solutions of this function are 3 and negative 8. So now let's do some examples here. If we multiply this out, I'm going to do the grid method again, just because it happens to be my favorite way to multiply polynomials. I know it's several students' favorite way. And I just make a bunch of boxes, and then I put basically what I have on the sides, and on the inside goes the multiplication. X squared, which is x times x, minus 10 times x, minus 10x, minus 6 times x, minus 6x, minus 6 times a minus 10, plus 60. So these will combine. X squared minus 16x plus 60. Right, this is in standard form. Oh, and essentially the solutions to this problem are, if I set these two factors equal to 0, right, when x is equal to 10 and when x is equal to 6. So these would be considered the zeros, right? The zeros or the x-intercepts, or you could call these the roots of the polynomial equation, all the same stuff. Let's try this next example. And right, this was factored form. And this here standard form. Now there's also a vertex form, but you've seen before, but we're not going to get into that in this part of the lesson. In problem 6, right, the zeros are going to be when x is 13 and when x is negative 12. So here's the zeros of this function. And to even be a zero, right, let's just keep it all in perspective about what that even means, is if I'm graphing this thing, essentially what's happening is I've got some parabola, right? And the x-intercept, I know by looking at this in the factored form, is going to be, it's a terrible arrow. Oh, if only my handwriting was as good as my math. Right, when x is at negative 12 and when x is at 13. So that's what this means in context, hopefully, from the graph. To be a zero of a polynomial is essentially to be the x-intercept. So here we go. You have a worked out example here, right? This is essentially a worked out example. And I've been adding these to your notes just so you can see, like, even without Minton's terrible handwriting, if I read this thing and we're trying to figure out, well, what the zeros are of this polynomial, hopefully by reading this, you could see, like, oh, yeah, 15 and negative 7. Super obvious. It's right there. If x minus 15 were equal to 0, you know, what would make the equation equal to 0? Positive 15, of course. And there's a worked out example. Here's one I'm going to do with you. That's going to be 0. So I say essentially, well, x plus 1 equals 0 and x plus 23 equals 0. The principle of the zero product property is that these two things are multiplied together and one of them has to be equal to 0. And what value for x would make that statement true? What value of x would make one of these two things being multiplied equal to 0? And of course, well, negative 1 would, and so would negative 23. So the zeros of this thing are negative 1 and negative 23. And in context, of course, Mr. Minton will just throw that in there. That means this graph, if you were to plot it into Desmos, would have x-intercepts at basically negative 1 and negative 23. Negative 23. So there you go. Let's take a look at a few more examples. So again, in section A, we just essentially have a worked out example of if, what if there was a number next to the x? How does that affect what the zeros are? And by using the distributive property, right, if here's a 3x and here's a 5, and you see how this is repeated, you essentially have this below, 3x plus 5 times x minus 4. And this is kind of the backwards way of looking at what one of the ways I've showed you how to multiply polynomials in chapter 5 using the distributive method. So with that in mind, right, if I'm looking at this next example, this is essentially 3, let's see, 3, I'm mistaken here. Well, it's already listed the 3x here, so that means this part must be minus 9. And then it's being multiplied by x plus 2. So here we go. We got minus 9 plus 3x and x plus 2. Apply the zero product property, right? You basically isolate both of these factors. You set them equal to 0, and then you solve for x. So what's the opposite of minus 9? Plus 9 to both sides. What's the opposite of times by 3? Divided by 3. What is 9 divided by 3? 3, of course, so one of the zeros is 3. And what's the opposite of plus 2? Minus 2. One of the zeros is minus 2. Give you a moment to get those little bits of information written down, and then we're going to move on to 2 examples. Here we go. If we're going to solve using the distributive property, right, well, one of our factors is essentially x minus 11. And then the other one of our factors is 7x minus 2. And if I now try to figure out, well, what are the zeros of this thing, right? If one of these two things has to be 0 for this thing to be equal to 0, well, let's just isolate one at a time. We're going to set it equal to 0, and then we're going to solve for x. So, right, applying the inverse operation, you're going to get 7x is equal to 2, which means x, you're going to have to divide by 7, is going to be equal to 2/7. So when x is 2/7, this equation here would be equal to 0. And let's find out what else. Right, add 11 to both sides when x is equal to 11. So the zeros of this function, right? The zeros or the x-intercepts are essentially 2/7 and 11. And all that means, right, on a graph, this thing hits the x-axis at 2/7 and 11. So let's try this other example. So in prior examples, you were trying to use a distributive method, but you needed 2 of something to occur, right? Like over here, you have x minus 11 twice. You have x plus 6 here, but it's not apparent. This is basically 3 times x plus 6, this up here. So if you factor out the 3, you get that. And now we have a condition where we can isolate what's happening with the distribution. So it's going to be minus 8x plus 3 times x plus 6. And all that's equal to 0. So now let's figure out what x has to be. And I'll use a different color for the other one. Well, this one should be obvious here, right? Subtract 6 from both sides. What must x be to equal 0? A negative 6. So one of the zeros to this polynomial is negative 6. This other one is going to take a little bit more algebra. Subtract 3 from both sides. Right, you're going to get negative 8x equals negative 3. Divide by the negative 8. The 0 is going to be at x is equal to 3/8. So your two zeros for your polynomial are 3/8 and a negative 6. So hopefully that helps. There'll be guided practice. It's in homework mode for you to check your answers. And please ask questions if you don't understand.